Good afternoon, my YouTube viewers. In this particular video, what we're going to be talking about is experimental design, and it's a framework for scientific inquiry. So, experimental design forms the backbone of empirical research, providing a systematic approach to investigating cause and effect relationships. Its methodology ensures that researchers can draw valid conclusions, minimum bias, and effectively allocate resources. So I've got a diagram here for you for the cycle of experimental design. So you've got observation, and then induction, then deduction, testing, and evaluation. And so that's a life cycle for empirical research methodology. So the process of conducting empirical research is as follows. 1, you define the research objectives. What are these specific research questions you aim to answer? The objectives should align with the scope of your study and help to shape your design. 2, design the research methodology. Choose a methodology that aligns with the research objectives. This methodology could be either quantitative, surveys or experiments, or qualitative, interviews or focus groups, depending upon the type of information needed. 3, conduct a thorough literature review. Review relevant literature to understand previous studies and their methodologies, which helps to identify gaps in knowledge and refine the theoretical framework. 4, develop a research design which should outline the timescale and tools for data collection, selection criteria for participants, and specific layout for presenting findings. 5, collect and analyze the data. Use primary sources like surveys, interviews, or experiments, but also secondary sources like existing reports or studies. And 6, present empirical findings, ensuring the information is clarified and visualized. One good way to present the findings is to start with an abstract, followed by an introduction, methodology, results, discussion, and conclusion. So you've got some principles of statistical experimental design. At its heart, statistical experimental design aims to structure experiments so that meaningful and unbiased results can be obtained. The foundation of any well-designed experiment is built upon these principles. And 1 is randomization, ensures that experimental units, e.g. individuals, plots, or items, are randomly assigned to different treatment groups. This minimizes the influence of confounding variables and ensures an unbiased comparison. 2, replication. Repeating the experiment or including multiple experimental units under each condition allows for the estimation of variety and increases the reliability of conclusions. 3 is blocking. Dividing experimental units into homogeneous groups or blocks and assigning treatments within each group helps reduce variability caused by known factors such as age, location, or time. 4 is control. Incorporating a control group or baseline condition ensures that comparisons can be made against a known standard, enabling the isolation of the treatment effect. 5 is treatment factors. Careful consideration is given to the factors, variables being tested, their levels, and their interactions to maximize the amount of information gained from the experiment. So that covers the basics of experimental design. And The next video are going to be some examples of experimental design, which we're going to cover. So I hope that you decide to watch the next videos on this subject.